I'm James Thorburgh. I teach CAD, mechanical design at Merced College, the community college in California. I'm also an EDD candidate at Fresno State, and I'm the president of a Hackerspace. So a lot of different things going on, and I'm going to combine kind of all of that in this talk. So the talk is Hackerspaces as the new CTE training ground, question mark. So I'm going to talk about CTE, career technical education. I'm going to talk about MOOCs and Hackerspaces, and also the link back to formal education. So CTE, who's familiar with what CTE is? Everyone? No? Okay, career technical education is what used to be called vocational, but it's now, everything's kind of risen up a little bit. So engineering, kind of applied engineering, health sciences, manufacturing, all that kind of stuff. I teach CAD, so 3D modeling, product design, those kinds of things is what I teach, and that's my real focus on that and product engineering. So that's what I'm going to focus on. So yesterday, Kathy showed this slide, or I guess Thursday night. And the keywords for connected age, just in time, anytime, the network. In her other book, which is out on the stand today, that her and Goldberg did, had this list. So some of the learning key terms, so self-learning, using horizontal structures, collective, decentered, network, open source, lifelong learning. This is really the key to what I'm going to be talking about here. So in CT, there's really complex topics, really kind of abstract things that you have to move down. So I teach a lot of drafting, which is taking 3D objects and representing them on 2D paper. And doing that so that you can send it to someone they can understand it anywhere in the world. Also, how things are going to fit together, how tolerances work, real engineering concepts, which are sometimes hard for people to understand. Also, the software equipment to do this is real expensive. CAD software is usually $5,000 to $10,000 a copy for professionals. Even in education, it's easily $5,000 a semester or a year for one package. So if you have multiple packages, then it's easily $10,000 of software a year for a program, plus equipment that costs tens of thousands of dollars. So that's the kind of framework from where CTE sits. And so right now, formal education is where that is, because formal education has the money for that, the experience doing the training. But is there another way? So that's where MOOCs are. Right now, you can go to and see this lectures from MIT on the open courseware. You go to the MOOCs, whether it's the parts of MITx or Coursera, and get content in those engineering subjects, as well as every other subject, but from really known professors with the coursework, but they still don't have access to the software and equipment. So you can kind of learn the concepts, but you don't get the hands-on practice, which is required for engineering. And of course, there's the dark side of MOOCs. The part that is the big discussion is MOOCs don't have good completion rates. A lot of questions on it, and no real good, solid research into what's really going on, just some general completion numbers and things that aren't very good. You can see right there, it's about 5% completion for people that sign up. I know I've started 2 at Udacity and not finished either of them. So I'm one of those people. So the question with MOOCs is, as well as all online learning, is that personal connection, which I think you're going to be talking about. So how do you establish that personal connection when there's 1,000 people in a class? And so that's where the Hackerspaces come in. So Hackerspaces, anyone familiar with Hackerspace? No one? A little bit? So Hackerspaces are community workshops, the easiest definition. They usually have some kind of wood shop, metal shop, electronics. Um, they kind of, depending on what the focus is, there's one in the Bay Area that's biotech. There's a lot that are just kind of wood shop, metal shop. Some are real small. I know there's a few that are in spaces that are about 700 square feet. And then there's large ones that are 50,000 square feet. So there's a whole range of size, focus, um, within that same term of hackerspace, where they're working together, they're helping each other, they're learning, they're teaching each other, and doing new things that are collective. And so that has that community aspect to it. So at the University of Washington at Seattle, they have what's called the Hackademia. So they have an interdisciplinary lab. They have students come down and work on projects with no direct instruction. So they give them a project in class, and then they go down to the space and learn how to use the tools and learn how to do some basic engineering work without any instruction on how to do it. And it's shown that they actually do learn something through that process. Hackerspaces have also been portals for people that had no experience coming in, developing products to be sold either on Kickstarter or actually starting commercial businesses, just the traditional ways of funding. There's a hackerspace, a for-profit hackerspace in San Francisco that's called Tech Shop, and they've spawned several commercial products for people that had no experience coming in. There's a hackerspace in China that people can go to and work directly with the large manufacturers in China to start their products.
James,
So
2 more minutes.
It's being used. And the last one is the community. So the part of the MOOCs is that you needed that connection. Hackerspaces, a real reason why people would join Hackerspaces is that sense of community. And the one that I'm starting, that's the most common term used to describe why people are there. It's we want the community, we want to talk to other people, we want to interact with other people, and then learn from them and teach them and all those things. So trying to tie it back to formal education, we have different ways to get access to knowledge. We have the community, and so if there's someone there that knows what they're doing, so in ours there's some people that, like me, are from academia. There's also people from industry that have a lot more experience in some things than we do. And then how do we tie that back to formal education and actual credit for knowledge? Can hackerspaces work with local community colleges and universities to kind of create some kind of articulation of, once you have this knowledge, can you translate that back into credit to be officially recognized? Or can you translate that to something that an employer can see besides just a project? So some places for future research. So the efficacy of non-formal STEM education. So how effective is non-formal education in STEM? How does that learning actually occur within a hackerspace? And just a lot more research on MOOCs in general. So that's my presentation.